Welcome back to In Pursuit of Life with Dr. Caleb. For those of you that might be new to this channel, my desire is to focus on reproductive health issues that can lead to infertility and pregnancy loss and highlight possible natural solutions to those issues to help others overcome or avoid altogether the kind of struggles and hardships that my wife and I went through on our journey to parenthood. In my last video, I started focusing on what normal reproductive health looks like, starting with the HPG axis. So that's the communication and management system that connects the brain to the reproductive organs. We're going to continue our focus on normal today by looking at spermatogenesis. Spermatogenesis is the process that occurs in males after going through puberty to develop spermatozoa or sperm cells. So sperm cells are the male gametes or reproductive cells, whereas the female gametes are the eggs. We will talk about those a lot more in the next video when I cover oogenesis, which is the production of the eggs. Gametes are very special cells because of the way that they carry genetic information or chromosomes from both the mother and the father and combine them to make a brand new and unique human being. Now, you probably already know that each one of us has genetic information in every cell of our body. So what is it about gametes that makes them so special? Why is it that only the gamete cells are used for reproduction and not something else like skin cells or hair cells? The answer is because they are haploid cells, which have 23 chromosomes, whereas the other cells in our body are diploid cells, which have 46 chromosomes. The genetic makeup for any human, excluding some abnormal variations, consists of 23 pairs of chromosomes for a total of 46 chromosomes. In simpler terms, 46 chromosomes make up the total sum of a person's genetic blueprint, whereas the gametes, the sperm and the egg, each carry half of the genetic information that makes up our blueprint. So when a sperm fertilizes an egg, the 23 chromosomes from the father and the sperm pair up with the 23 chromosomes from the mother and the egg to create that total 46 chromosome blueprint for the baby. That is why the gametes are so special. So now let's talk about how spermatogenesis actually works. After going through puberty, spermatogenesis is a continuous process that occurs in the seminiferous tubules of the testes. So this is a process that can take 74 days. It starts with an immature sperm cell or a stem cell that goes through a complex multi-step process that develops it into a mature and healthy sperm cell that is capable of fertilizing a female egg. So this process starts when follicle-stimulating hormone and luteinizing hormone from the pituitary gland interact with the gonads. So luteinizing hormone is going to go to the Leydig cells in the testes, which helps with production of testosterone. And then the follicle-stimulating hormone is going to go to the Sertoli cells to stimulate the growth and maturation process of those immature sperm cells. So when the Sertoli cells are stimulated, they're going to support and nourish the immature stem cells by giving them nutrients and important products to help them grow. So as that cell grows, it'll develop and get transported from the outer surface of the seminiferous tubule to the central channel. That process includes going through what's called meiosis and mitosis. You might be familiar with these from biology class. Mitosis is when a cell is going to replicate. It's going to completely copy itself. And it's important to note also that these immature stem cells are actually diploid cells. They actually have the 46 chromosomes. So when that mitosis or replication occurs, all that information is copied and we create two more cells that are, one is going to be another immature stem cell, the other is going to go on and continue to develop and differentiate as it moves towards becoming a mature sperm cell. So what occurs during the differentiation process is where we take each of the chromosome pairs and we take pieces from each of those chromosomes and combine it into one unique new chromosome that will be a mixture of the genetic material from the father and the genetic material from the mother. So after you do that through all 23 chromosome pairs, that creates that half blueprint for a unique human being that's going to be presented or available in that mature sperm cell. So that goes through that process. So once we have that differentiation, once that genetic kind of mix and match occurs, then we'll go through the meiosis process where those pairs start to get pulled apart, and then we have different unique possibilities for each sperm. So depending on what sperm gets there and fertilizes the egg will depend on which genetic material is actually presented or combined with the genetic material of the egg. And this is where we get a lot of differentiation or variation within families. For instance, with our son, me and my wife both have brown hair. I have hazel eyes and she has brown eyes, and our son was born with blonde hair and blue eyes. So after going through the mitosis and meiosis processes, the journey from a individual or immature sperm cell can actually generate 4 mature sperm cells because of the way that genetic material is split into 2 different cells and then split into 4 cells from there. As we're going to talk about in our next video, eggs go through a little bit of a similar process, but the time frame of when things occur in females is going to be a lot different than the time frame of how things occur in males. So join me in the next video as I look more deeply at oogenesis, or the process of creating eggs. Until then, take care and be blessed.